Hello everyone, before we move on to the case study, I would like to briefly introduce building services. Building services refer to all internal systems that support the operation of the building and provide a safe, comfortable and efficient environment for occupants. These systems are commonly known as mechanical and electrical or M&E and included electrical, mechanical, plumbing, fire protection, communication system, elevator and escalator. Regular inspection and maintenance are essential to ensure these systems continue to operate safely and efficiently throughout the building lifespan. For this case study, we focus specifically on the escalator system because it is served as one of the main vertical transportation systems in one marine mall. The mall uses a parallel escalator configuration consisting of the upward and downward escalator to provide smooth passenger circulation while ensuring safety, accessibility, and operational efficiency. Next, we will move on to the theory of escalator. An escalator is a motor-driven continuous moving staircase designed to transport passengers efficiently between different floor levels. The concept of the moving staircase was first patented by Nathan Ames in 1859, while the first practical escalator was successfully introduced by J. W. Renault in 1869. Since then, escalators have evolved significantly in terms of mechanical design, passenger safety, and energy efficiency. Depending on the building layout, escalator can be installed in several configurations such as parallel, multi-parallel, crisscross, and spiral. Most commercial buildings, including shopping malls, commonly use the parallel arrangement because it provides efficient passenger flow while maximizing the available floor space. A standard escalator is typically installed at an inclination angle of 30 to 35 degrees and operates at a speed approximately 0.6 to 0.65 meter per second. Under an ideal condition, it can transport up around to 90,000 passengers per hour. The escalator operates using the electrical motor that drives the gearbox, drive shaft, and step change system, allowing the step to move continuously while remaining level throughout the journey. In addition, its overall performance and energy consumption are influenced by factors such as passenger load, operating speed, travel height, and the passenger behavior. For this case study, our group selected one Marine Mall which is located in Seri Kembangan, Selangor. It is a shopping mall that serves as a community hub, providing various retail shops, restaurants, and entertainment facilities. The mall was chosen because it has a well-designed escalator system that supports efficient movement of visitors between different floors. The building consists of one basement level, 3 retail podium level, and 1 car park level. To ensure smooth vertical circulation, the mall is equipped with a total of 8 parallel escalators comprising 4 upward and 4 downward escalators. These escalators are strategically located in the central atrium, allowing visitors to move conveniently between floors while reducing congestion and improving overall accessibility within the building. In this presentation, our focus is on the parallel escalator system and how it contributes to efficient passenger circulation and enhances the overall functionality of the shopping mall. The objective of this presentation are to understand the escalator system used in our case study building, which is one Marine Mall. First, we aim to identify the type of escalator used and explain its function within the shopping mall. This helps us to understand why the selected escalator system is suitable for handling high pedestrian traffic. Second, we will study the main component of an escalator and explain the installation process to understand how the system is constructed and operated safely. Finally, we will explain the operating principle of the escalator, including how its mechanical and electrical components work together to provide a smooth, safe, and efficient vertical transportation for building users. One Marine Mall uses a parallel escalator system. In this arrangement, the upward and downward escalators are installed side by side on each floor levels. This design allows passengers traveling in opposite direction to use separate escalators, resulting in a smoother and more organized flow of people throughout the building. It also helps to reduce congestion, especially during weekends, public holidays, and peak shopping hours when visitors' traffic is high. In addition, the parallel escalator system improves accessibility by allowing visitors to move conveniently between different floors. This makes it an ideal choice for shopping malls, where efficient vertical circulation is essential for providing a comfortable shopping experience.
Assalamualaikum, my name is Ahmad Nadzif. So for the next slide is component of the system. A successful escalator system begins with its component method. A bunch of components are being used in order to ensure the functionality of the escalator, not solely about its step movement but also regarding its safety features and the entire system. So for the first component is steps. The steps provide a safe standing surface for passengers. They are designed with grooved surface to improve grip and reduce slipping hazard. The steps remain level during travel to ensure passenger comfort and stability while moving between floors. It is located along the incline moving pathway of the escalator. The second component is handrail. The handrail provides physical support and balance for passengers, especially elder users, children, and people carrying items. It enhances passenger safety by reducing the risk of falls while riding the escalator. It is located along both sides of the escalator. So for the third component is drive motor. The drive motor converts electrical energy into mechanical energy. It generates the force required to move the entire escalator system, including the steps, handrail, and chains, at a constant operating speed. It is normally located in the upper landing machinery area. The next component is drive chain. The drive chain transmits mechanical power from the drive motor and gearbox assembly to the drive sprocket. It ensures efficient power transfer and help maintain smooth, continuous movement of the escalator steps. The chain is designed to withstand heavy load and constant operation while minimizing slippage. It is located within the machine section, usually at the upper landing, connecting the drive unit to the drive sprocket. So for the next component is step chains. The step chains connect all the steps together and transfer power from the drive system to the step. It ensures synchronized movement and maintains the correct spacing between steps throughout operation. It is located underneath and attached to the step within the truss. For the next component is guide tracks. The guide tracks direct the movement of the step roller. They ensure the step remain horizontal while carrying passenger and properly collapse into a flat chain when returning underneath the escalator. It is located inside the truss along the full escalator line. So for the next component is the drive sprocket. The drive sprocket is a toothed wheel that engages with the drive chain or step chain. As it rotates, it transfers power from the drive system to the step chain, causing the escalator step to move continuously along their designed path. It is located amount on the drive shaft within the upper landing machinery's compartment. The next component is landing platform. The landing platform provides a stable and level area for passengers to safely board and exit the escalator. It also houses several safety and maintenance access components. It is located at top and bottom end of the escalator. So for the next component is the drive pocket. The drive pocket is a toothed wheel that engages with the drive chain or step chain as it rotates. So for the next component is comb plate. The comb plate creates a smooth transition between the moving step and the stationary floor. Its interlocking teeth minimize gaps and help prevent shoes, clothing, or object from becoming trapped. It is located at the upper and lower landing entrance. For the next component is balustrade. The balustrade acts as a protective barrier between passenger and the moving machineries. It also supports the handrail and help guide passenger movement safely along the escalator. It is located along both sides of the escalator. Next component is skirt panel. The skirt panel forms the smooth vertical surface alongside the moving step. It helps prevent passenger shoes, clothing, or object from becoming trapped between the steps and the side structure. The panel also guides the movement of the step and enhance passenger safety. It is located on both sides of the escalator adjacent to the moving steps beneath the balustrade. The next component is truss. The truss serves as the primary structural backbone of the escalator. It supports the weight of all mechanical components, including the steps, track, chains, drive units, and passengers. It also transports the load safely to the building's supporting structure. It is located between the upper and lower landing beneath the escalator. So for the next component is controller panel. The controller panel acts as the brain of the escalator. It manages startup, shutdown, speed control, fault detection, safety monitoring, and communication between electrical and mechanical components. It is usually located in the upper landing machinery compartment. The next component is emergency stop button. The emergency stop button allows passenger or maintenance personnel to immediately stop the escalator during emergencies such as passenger falls, entrapment incident, or mechanical malfunctions. Activating the button cut power to the drive system and engage the braking mechanism. It is typically located at the upper and lower landing near the escalator entrance and exit where they are easily accessible. So for the next component is safety sensors. Safety sensors continuously monitor the operating condition of the escalator. They detect abnormalities such as step chain breakage, step misalignment, handrail speed difference, complete obstruction, skirt entrapment, overheating, or foreign objects. When a fault is detected, the sensor automatically stops the escalator to prevent accident and equipment damage. It is located throughout the escalator, including the complete step track, handrail system, drive machinery, and skirt panel. The next component is brake system. The brake system safely stops the escalator during emergencies, maintenance operation, or power failure. It prevents uncontrolled movement and protects passengers from accident. It is located on mount on the drive, motor, or drive shaft assembly. The last component is handrail drive system. This system drives the handrail and keep it moving at approximately the same speed as the steps. This synchronization prevents passengers from losing balance due to speed difference. It is located in the upper landing drive assembly.
Installation of the escalator requires 3 stages to be done, which the first stages is a site preparation, where the escalator needs to be placed, required to be a pit for the lower and upper escalator trusses. And as well as in the site preparation, it is required for the subcontractor hired by the main contractor to prepare an electrical wiring to allow electric to travel into the escalator and allow it to function. It is a factory stages where the escalator will be built from the scratch. And in these stages, the first thing to be done is actually a side frame will be attached to a drive system, where it will be then called as a transition assembly. This transition assembly allows a handrail and a step to be looped around the escalator as it's functioning properly. After attaching this side frame to the drive system and make it a transition assembly, it will then be lowered into a trusses and then attach it to the trusses itself. Before it will then be installed a complete, where it will become the final step before a person get down or get into the steps of the escalator. Then the step chain will be rolling out before it will be greased on the pin section, and then the step will be positioned equilibrium to the pins that has been greased before it will be locked with the pins by using a spring flip. And then after all the steps has been locked with the pins of the step chain, it will then be fed into the assembly trusses that has been installed beforehand. The control system, or also being called as the inverter of the escalator, will be integrated into the system, and which this inverter will be also set with a programming to allow the movement of the escalator based on its direction of rotation. And then finally it will be installed the balustrade alongside the escalator, which enclosing the entire handrail and the steps of the escalator. Installation stages. This is where complete escalator from the factory will be transported to the site by using a special equipment. And by using a special equipment like a crane, it will then be lifted into the building that is need to be attached to. And within the building, it will then be lowered into a pit that has been prepared beforehand during a site preparation with an accurate alignment to avoid any mistake during installation, which could disturb the functionality of the escalator itself. It is then required the upper trusses of the escalator to be installed first, before followed by the lower trusses of the escalator, and then being braces by the cross braces to lock both of these trusses together. It is then, as a final stage, a requirement to for electrical wiring to be connected into the escalator system, as well as some escalator calibration, such as the speed of the escalator will be then set up during these stages. Escalator require different compartments from the escalator to work together and compress to allow a proper movement of the escalator and to allow the transportation of the passenger from a different level to a different level. The use of the power supply and a transformer. The power supply for the escalator will be provided from the main building of the Emery Mall itself. This power will be traveled through the electrical wiring installed beforehand during the construction process. The power supply from the TNB to the Emery Mall gain around 22 kilowatt, which is a high number of power and electric power. Within the Emery wall, it has its own substation with a transformer that will be stepped down this 32 kilovolt to 11 kilovolt before it will then be sent some of the power supply to the escalator system itself. Within the escalator, it has its own transformer that will help to step down this power from a certain amount to the required specific or a standard amount of power used for the escalator system, which is around 380 volt to 450 volt, which is suitable for the use of the escalator system that does not require a high voltage of electric. Component involved in the operation of the escalator is an inverter and a contactor. It is also called as a control system of the escalator or known as a brain for the escalator itself, as it allows the movement for the electrical motor to be done and to move the entire system of the escalator properly. The inverter functions by reducing sudden start and steps, improving passengers' comfort, while the contactor helps in control the motor power supply. And in inverter and the contactor component, it is complies with the safety features, which any abnormal activities happen on the escalator itself will stop the escalator and giving the emergency code during the stop section. The next component involved in the operation of the escalator is the electrical motor. The electrical motor is fundamental component that connect between the inverter and the main chain, which this component will produce a movement of torque in a certain direction depending on the inverter that has been programmed beforehand. Sudden change in the programming to change for the torque direction need to be avoided, as it could damage the motor cycle. And a proper function motor, it also means a proper movement of the gear of the escalator. The next component involved in the operation of the escalator is the main chain. Main chain function to transmit the energy of a torque and a rotational movement from the electrical gear to the sprocket or a drive gear to allow a smooth movement of the step chain during the operation. Excessive view of this main chain will eventually break apart this main chain and will automatically shut down the entire system of the escalator, as this compartment complies with a safety measure and will directly send a signal if any abnormal thing happen to the main chain itself.
The drive gear or sprocket transfer power from the motor to the step chain and handrail chain. This allows both components to move simultaneously and at the same speed. The synchronized movement is important because passengers often hold the handrail while standing on the steps. This helps maintain balance, improve comfort, and ensure safe operation of the escalator. The handrail chain and step chain are important mechanical components in the escalator system. The step chain moves the step, while the handrail chain drives the handrail at a similar speed. During the site visit, blue rollers were observed on the step chain system, helping to reduce friction and provide smoother movement. Regular lubrication and maintenance are carried out to ensure efficient operation, reduce wear, and extend the lifespan of the escalator. The handrail chain and step chain are important mechanical components in the escalator system. The step chain moves the moving step and handrails are the main parts that passengers interact with. The step move continuously along guide tracks to transport passengers between floors, while the handrails move at the same speed to provide support and balance. At the landing area, the step flatten to allow safe boarding and exiting. The synchronized movement of both components help ensure a safe, comfortable, and efficient journey for users. The escalator at Emery Mall is designed to transport passengers efficiently between floors. It uses a parallel configuration where one escalator moves upward and the other moves downward, allowing smooth two-way circulation. The system is also equipped with motion sensors that detect passenger preference and activate the escalator. When no passengers are detected, the escalator can slow down or stop to improve energy efficiency. To conclude, the escalator system at Emery Mall functions efficiently in transporting passengers between floors. It operates through a combination of electrical and mechanical components and uses a parallel design for smooth passenger flow. Safety features and regular maintenance help ensure safe and reliable operation. Overall, the system performs well and meets the transportation needs of mall users. Thank you for listening to our group presentation on the mechanical escalator system. That's all from us. Thank you. Thank you for listening to our